So this is this is letter from the president. So I believe this is the last part of the Margin Dogo project, and this is where we like derive insights from our data, all the analysis and cleaning and aggregation that we've been doing from the walkthrough one. I believe this is like the points where we'll now gather the insights and like put it together. So moving on. Hey, how have you been? I am moving to another project soon, so this might be the last time we work together for a while. I thought you would appreciate this. They have arrested the corrupted officials. So we still have a bit of analysis to wrap up, and then we need to create a table to track our progress. Let's start with the last bit of analysis. So I used to be tempted to put all of the columns from the table in one place or table, then analyze the data. But in a data set of this size, we are going to run into performance issues. So we should rather spend a minute thinking about the questions we still have, create queries to answer them specifically. Doing this means that we will only use data we need to answer our question. Let's summarize the data we need and where to find it. First off, all of the information about the location of a water source is in the location table, specifically the town and province of that water source. Water source has the type of source and the number of people served by each source. Then visit has queue information and connect source ID to location ID. There were multiple visits to sites, so we need to be careful to include duplicate data. In brackets, where visits count is greater than 1. Well pollution has information about the quality of water from only wells. So we need to keep that in mind when we join this table. So it looks like these are the tables that we'll majorly be working with in this workshop. The location table, the water source, the visits, and the well pollution. And they gave us information in all of these tables. And also reiterated that the visits table is like the connecting table to most of the other tables. So previously, we couldn't link previous provinces and towns to the type of water sources, the number of people served by those sources, queue times, or pollution data, but now we can. So what type of relationships can we look at? So these are part of the issues that we are going to be solving in this walkthrough. So things that spring to mind for me. One, are there any specific provinces or towns where some water sources are more abundant? That's the first question in this part. The second one, we identified that tapping home broken taps are easy wins. Are there any towns where this is a particular problem? Excuse me. So, I want to know if there's any town that this particular tapping home broken are like it's like a particular problem. Like I believe where tapping home broken are like more or most occurring, that kind of situation. So to answer question one, we will need province name and town name from the location table. We also need to know type of water source and number of people served from the water source table. The problem is that location table uses location ID. So the primary key in the location table is location ID, while water source only has source ID. So we won't be able to join these tables directly. But the visits table maps location ID and source ID. So if we use visits as the table we query from, we can join location where the location ID matches, and water source where the source ID matches. Before we can analyze, we need to assemble data into a table first. It is quite complex, but once we are done, the analysis is much simpler. So basically, we want to combine the location table and the water source table. We want to see the number of people served and the water sources by provinces and town. However, we can't combine the two tables together because there is no common column between the two tables. So we have to involve the visit table. The visit table is a connecting table between the location table and the water source table from what we just read. So moving on. So they said, okay, so they are breaking down how we're going to do it. Start by joining location to visits. and this should be what we would get when we start doing it. I believe this would come in handy. So we're going to first join the location table to the visit table, and I believe the common column between the two tables is the location ID, and this is the result we'll get: the province name, town name, visit count, and location ID. Now we can join the water source table on the key shared between water source and visit source. So the key shared is like the column shared between the water source and the visit source. And the column shared, which they already mentioned to us earlier, is the source ID. So it's the source ID column that will join the water source and the visit table, which the result should be this when we run it. Note that there are rows where visit counts is greater than 1. These were the sites our surveyors collected additional information for, but they happened at the same source or location. For example, add this to your query where visit source location ID is equal to this ID. So I believe what this is saying is that we're going to definitely have repetitions in our data, and it's going to be exactly the same thing. Like a location ID or a source ID would appear more than once, and the record in that particular row will be the same thing: the province name, town name, the location ID, the type of water, and the number of people served. It's going to be the same thing. They said we should use this particular location ID to filter our table after running it like this. And this is what we'll get. So the province ID, the town name, just the visit count increasing, the number of times that the location was visited. But the other records will be exactly the same thing. So because of this, we are going to select our visit count, visit underscore count equal to 1. Let me read what it says. There, you can see what I mean. For one location, there are multiple AKHA001003 records for the same location. If we aggregate, we will include these rows, so our results will be incorrect. It's saying that if we aggregate the data, for instance, if we do like a sum or a count, it's just going to sum up all the values in these rows, and it's going to give us an incorrect record at the end of the day. Because it's not like a total that I want to see. We want to see like the record, the number of people that is served in that source. We want to see the number of people served and the type of water source. So if we aggregate it, like if we add it up, it's going to, of course, add all of these values, and it does not reflect truly what the number of people served. Is already giving a sum of all the times that they visited. So he said to fix that, we'll just select, after writing our query, we'll use a where clause to filter out where the visit count is equal to 1. So if we do this, we are going to avoid duplicate data. So we said remove where visit dot location ID is equal to this, the ID that we used earlier, and add visit underscore count is equal to 1 as a filter. Okay, now that we have verified that the table is joined correctly, we can remove the location ID and visit count column. Add the location type from location and time from visit result. We're going to be removing the location ID and be adding the time in queue for each location and the location type. Location type is whether it's rural or it's urban for each location. Please, are we following? Let's not be like
Yeah, okay, I'm
not
here.
communicating.
Perfectly.
Find
Thank
out.
you. Please, you are flowing.
Okay, thank you. So we get this table. When we add add the location type column from location and time in queue from visits to our result set. So they have given us what the table would look like when we add it. Says last one. Now we need to grab the results from well pollution table. This one is a bit trickier. The well pollution table contained only data for well. If we just use join, we will do an inner join. So that only records so that only records that are in well pollution and visits will be joined. We have to use a left join to join the results from the well pollution table for well sources and will be null for all the rest. Play around with the different join operations to make sure you understand why we use left join. So basically saying we should also add the well pollution table to this table, and we are going to use the visit table also to connect it. And we shouldn't just use join, because when we use only join, it's inner join that we'll be doing. We should make sure to use a left join so that it gives us the entire records in this table and also adds the entire record in the well pollution table. Saying that if we use just join, the inner join is just going to give us the well records, because inner join will give us records that is common to the both tables. So since the well pollution table is not going to have records of other type of water sources, it's not going to return it if we use an inner join. So it's saying we should use a left join so that it returns all the records in the this particular table, and then it's now join the records in the well pollution table. It also says that we should use other types of join so that we understand why we use the left join, so that we'll see the difference in the output between an inner join, a left join, a right join, and a cross join, which I believe. And I think there's an inner join as well, the self join rather. Okay, so it gave us the code. It says here is the code. This table assembles data from different tables into one to simplify analysis. So the last join is going to be we're going to get the results from the well pollution table, and excuse me, we're going to do a left join of the well pollution table, and the connecting column is the source ID is here. So when we're answering it, it'll be easier to, since you already have the code. So this table contains the data that we need for this analysis. Now we want to analyze the data in the results set. We can either create a CTE and then query it, or in my case, I'll make it a view so it's easier to share with you. I'll call it the combined analysis table. So it's saying after we get the results from from this query, we should either make it a CTE or a view. We should just store it in a table. And it's saying in his own case, so he's going to make it a view so that it will be easier to share, which I think will also be better, because a view gets stored temporarily, like a temporary table. So it gives us the code, says here it says the create view, and it calls the view combined analysis table. So, and the view is going to give us the water source, type of water source, the town name, province name, the location type, the number of people served, time in queue, and the results from the well pollution table. And we should not forget that to avoid duplication or duplicates rather, we would make visit count equal to 1. Reading on, it says this view creates a table that pulls all the important information from different tables into one. You may notice our query is starting to slow down because it involves a lot of steps and runs on 60,000 rows of data. The last analysis. The last analysis. We are building another pivot table. This time, we want to break down our data into provinces or towns and source types. If we understand where the problems are and what we need to improve at those locations, we can make an informed decision on where to send our repair teams. We did most of this before, so I'll give you the queries I used, explain them a bit, and then we'll look at the results. The queries I'm sharing with you today are not formatted well because I'm trying to fit them into my chat messages, but make sure you add comments and document your code well so you can use it again. So it's saying that the query that is going to be giving us is just going to give us a query, then explain it, and we should add comments by ourselves. Like usually they would comment when they create a city and all of that, they will add comments to it so that in later times when we come back to it, we can understand what it is doing. Perhaps we have forgotten. So he's saying we're going to format it very well by ourselves and add all those comments by ourselves, which I believe we would do when um we are running the walkthrough or we're doing it on our own. So this is the query. And the output of a query is supposed to be a pivot table, like he earlier stated. Okay, let's go to the explanation. Okay, so this is a city actually. Province totals. Yes, this is a city. So you should get a table of province names and summed up populations for each province. Let's look at it here. Select province name, comma, sum of people served from combined table analysis, the view earlier created. So that's what this query is outputting for us. It's going to give us the province name and number of people served in each province. Okay, let's read on. The main query selects the province names, and then, like we did last time, we create a bunch of columns for each type of water source with case statements, sum each of them together and calculate percentages. Wow. Okay. So if we remember from the MCQ 2 or 3 that we did, that we created a pivot table for days of the week and I think time of day. So that's kind of the same thing that we're replicating here. But we're going to be using province name and number of people served. So I believe the way it's going to come out, the columns would be the type of water sources, and it's going to come out in percentages. So it's going to give us percentage of the type of water sources in each water source. It's going to be like a pivot table, and the columns will be the types of water sources, and the results in the columns will be the percentage of people served in each water source by province. Since it's province name that we are selecting from the main query. Okay, so we join the province totals table to our combined analysis table so that the correct value for each province PT dot total people served value is used. Finally, we group by province name to get the provincial percentages, which I just explained. Is going to be giving us, I believe the province name will be the rows, then percentage in each province of the number of people served will be the values in each cell per se. Then the columns will be the type of water sources. Okay, so run the query and see if you can spot any of the following patterns. So say when we run the query and get our results, we are supposed to spot any of these patterns. One, look at the river column. Sokoto has the largest population of people drinking river water. We should send our drilling equipment to Sokoto first so people can drink safe filtered water from a well. So remember at the beginning of the walkthrough, the letter part where it said that we want to convert all our data into understandable formats for people that work on it. So I think this is what this part is like technically saying. So that when people see the data sets or the final results, they can draw insights like just looking at it that, oh, okay. For instance, one thing it's saying is that in the river column, the Sokoto province, I believe Sokoto to be a province here, will have the largest population of people drinking river water. So the recommendation in quotes will be that they should send the drilling equipment to Sokoto first so that people can drink safe filtered water from a well. Next, the majority of water from Amanzi comes from taps. I mean, this would show in the pivot table that we are going to run. But half of these home taps don't work because the infrastructure is broken. I believe this should be tap in homes broken. We need to send out engineering teams to look at the infrastructure in Amanzi first. Fixing a large pump Treatment plants or reservoir means that thousands of people will have running water. This means they will also not have to queue for water. So we improve two things at once. Like I stated, these are like just recommendations from what the previous table will be showing us. The first one was about river, and this one I believe should be taps in homes broken, since it said taps that need fixing. So it's saying the Amanzi province, their infrastructures don't work. So I believe like they will have a large number of tap in homes broken. That's what it's saying. So we need to send out engineering teams to look at the infrastructure in Amanzi first. Then fixing the large pump will mean that they have access to running water and also reduce their queue times. Spot any other interesting patterns. So I believe they will expect that we'll be able to note out other things. So they spoke about just two water sources. So maybe we'll be able to see other patterns in other types of water sources. So, okay, I made another graph to help us see the patterns. So this is the graph from the um the pivot table that we're going to create. The is this red or orange now? Orange. Orange legend is tapping home broken. Okay. The yellow is tapping home, so which is the highest number. Then tapping home broken, okay, which we earlier assumed from the insight there. And we can see that the number is actually is a lot. So, and actually has the highest number of tapping homes broken compared to the other provinces. And the Sokoto province, let's see what well Biodeti well is the green. Yes, so Kilamani actually has the highest and Sokoto. So this is 5%, this is about 10%. But I mean, I spoke about Sokoto, so it's probably expecting, I don't know, maybe the MCQ ask us about a question about Kilamani, who knows? So this is a trend, anyways. Tap far. Is it dark? Is this blue or black? Can we see the graph? I'm the only one talking. Please, I think somebody else should spot a pattern or something that they can observe from this tap. Yeah, oh, yeah. Oh, please unmute your mic and talk. Oh, the graph is in front of us. Or should I call somebody? Have I lost people? These people should talk. Let me know. Should I go back? Should I come back? Are you lost? Okay, did I go back? Okay. Should I call names? Gani app.
Okay, can I come?
Okay. Yes, please.
I think this is showing the what's it called? The graph is showing the pattern of access to water according to the sources in each of these locations. So it's showing the correlations among all the existing water sources, I guess.
Okay, thank you, Michael. Someone else should say something, please. Okay. Like wow, call names like this now. Ganiat, are you there? Unmute your mic and talk. Oh, yeah, oh, yeah, oh, yeah.
You want me to help you? I can be unmuting their mic. Oh.
Unmute the mic. Unmute Gania's mic.
Fresh.
After Ganiat, Pauline. Oh, yeah, oh, yeah. Please say something. I mean, the graph is here and it's a lot of things to see. So say something, anything.
While you are muting their mic, let me talk my own before you call me and unmute my mic.
I would have loved
Okay,
to
please.
mute your own back, but it's good.
So I think that the graph is showing us the various sources of water at each location or the region. And from the graph, you can see the highest source of water from the region. For the Amazi, you can see that tapping home is the major source of water for that region, followed by tapping home broken, and then the least of it there is the grey one, bion dirty water. So I don't think those people will have major issues because that is least. And then same thing goes for Akatsi, although they have two major sources of water, they have the purple and the black. The purple is tap nearby, and the black tap far. So that means these people have to go long distance to get water. So this might not be really good. Then I think pretty much the length of the bars represents the highest or their most used source of water. So I believe I'm passed out something. Thank you for listening.
Yes, thank you very much, Fortune. So it's like Ghanaians is not ready to answer me. Pauline, please can you contribute to this? Is Pauline here? So that everybody's ghosting me like this night. Idris, good evening. Please say something. Nobody's saying anything. No. Temitope, please help us say something about the graph. Any pattern that you can see, anything.
Oh, sorry. I don't know that I'm muted.
Thank you. Please go ahead.
Yeah, like Fortune mentioned, from what you can see on the graph, we can see different patterns of the sources of water at Majindogu at different locations. Explaining the ranges of where you have where people at this location have sources to all these all their water. For instance, if you look at Kimani, you can actually tell that the highest sources of water is a tap FAR, and at other sources you can also see the sources where we have more access than the others. So just to cap it, it's showing us the sources of water at Majidogu per location. Thank you.
Thank you very much, Idris. Okay, so let's proceed, not to waste
I'm
our time.
sorry.
Okay.
I could hear my name. My system wasn't the sitting room. I was in the bathroom. I just came out now. I'm sorry.
No problem.
What
I'll
was it
call you.
again? You
Ma?
call me. All right.
Yes.
Oh, yeah.
Thank you. So, reading on, it says, let's aggregate the data per town now. You might think this is simple, but one little town makes this hard. Recall that there are two towns in Majindogu here called Harare. One is in Akatsi and one is in Kilimani. Amina is another example. So when we just aggregate by town, SQL doesn't distinguish between the different Hararis, so it combines their results. So it's saying that we should aggregate the data per town. What we've been doing since we didn't aggregate, we're just giving the whole list of data per province, per town. So now it's saying that, okay, all these provinces, we should now aggregate data per town. However, there is a little issue. There are different towns with the same name in some of the provinces. Give an instance of Harare, another instance of Amina. They have the same name, but they are actually in different provinces. But if you just aggregate directly, you just go by town straight up, it's going to aggregate these data together, which we do not want because technically they are different towns, they just have the same name. So it's saying to get around that, we have to group by province first, then by town, so that the duplicate towns are distinct because they are in different towns. So he's saying that to get around the issue of one town having